We're going to look at modeling with variation. So there's three types of variation we are going to look at today. There's direct variation, and we're going to define these kind of quickly, which we will just say y is equal to k times x. So you multiply with direct variation. And it is, as one thing goes up, as x goes up, y goes up, or as x goes down, y goes down. Inverse variation, you divide. It's just this relationship: as x goes up, y goes down; as y goes down, x goes up. But the key is kind of to think about divide. And then joint variation is when you multiply by more than one thing. So we'll just say y is equal to k times x times z. In all situations, the variables, and we'll change them when we go through these examples as far as what variables we use to fit the problems. But k is a constant. That's called the constant of proportionality. I can't fit that on that line. It will be a part of every question. That'll be a big part, is finding k. It is what relates the variables in the situation. It also is what will take care of different like units things. We won't talk much about units in this video, but k is what takes care of your different units. Okay, so here's some steps, and you can pause and read through those, and we're going to go through them in each of these problems. So this first one, it says a distance a ball rolls down an inclined plane is directly proportional. So we want to figure out what kind of relationship to the square of the time it rolls during the first second. During the first second, the ball rolls 8 feet. How far will the ball roll after 3 seconds? So this is a question you could probably, figure this out just by counting, but we're going to use this idea of direct proportionality, or direct variation. So we're going to use y is equal to kx because it's directly proportional. So let's use distance, because we know the ball rolls a distance. Let's use d, and then square of the time, let's use t. So distance is directly proportional, k, to the square of the time. So once you find your formula, then you just plug in what we knew. So we know the ball rolled 8 feet, so 8 is equal to k. Sorry, I made an error. I'm going to cut that out, and this is supposed to be 1. So let's go back. Time is 1. You won't even see what I did originally, but I substituted in the wrong time. So it's during the first second the ball rolls 8 feet. So let's do 8 is equal to k times 1 squared. And then that means k is equal to 8. Let's get rid of this formula. Sorry, this is messy. Okay, so now k is 8. And then d is equal to 8 times t squared. And now I can substitute in my 3. So I know d is equal to 8 times 3 squared. And so d is 72 feet. Okay, so if you can, pause the video and try number 2. Okay, so number 2 says the number of square tiles needed to tile the floor is inversely proportional to the square of the length s of the side of each tile. So n is inversely proportional, so that means we're going to divide by the square of the length s of each tile on the side. Okay, and then we're told that 180 tiles with 6-inch sides, it takes 180 tiles with 6-inch sides to tile a floor. And so that gives us n and s. So 180 is equal to k over 6 squared. When you multiply by Let's see, what do we get? We multiply by 6 squared, we get 6,480. So multiply both sides by 6 squared or by 36, and you get 6,480 is equal to K, which is great because now we have an equation. And then how many tiles with 9-inch sides will it take to tile the same floor? Our side S is now 9. So N is equal to 6480 over 9 squared, or over 81. And that gives us 80 tiles. Okay, go ahead and pause the video and try number 3. This one says the cost varies jointly with length and width. So we have the cost, and the varies gives us our constant, and then with length and width. Varies jointly means to multiply. And we know the cost, 734.40. We don't know K. We know the length is 9 and the width is 12. So we can divide by 108. 9 times 12 is 108 to solve for K. That gives us 6.8 for K. And that also gives us our equation. So C is equal to 6.8 times the length times the width. And you look back at the problem, well, what's the problem asking for? It says, then what does an 8 foot by 14 foot patio cost? So it's asking for cost, and we know our length is 8 and our width is 14. So we plug those in to our formula we've written, and the cost is $761.60. You can use your calculator to grab that value. Okay, number 4. Pause the video and try number 4. And as you're reading through this, identify the variables, the time required. So that's, we have T. To process a shipment of oysters varies directly with number of pounds. So we'll use equals K, and we'll use P for pounds. It gives us that in the shipment, and inversely with the number of workers. Inversely means to divide. So there is your equation. And then we have 3,000 pounds. So that's 3,000 pounds. And 6 workers. And the time is 8 hours. And then it asks us something else. But that is how we find K. So you can do this, a couple different ways. You can reduce this or multiply by 6. Let's reduce. That goes in 500. And then divide by 500. And we'll go ahead and use the decimal 0.016 when you divide both sides by 500. Okay, and then notice, hopefully you're feeling some rhythm with these problems. You find an equation, you substitute some values, you find K, you write your new equation. So T is 0.016, and then we have P over W. And then now we can use this to find time. So we have 5 workers and 4,000 pounds. Make sure you put them in the right spot, as I just put 5 in the wrong spot. And that is 12.8 hours. We don't normally talk about time in terms of like 0.8 hours. So if we want to do 0.8 times 60, that's 48 minutes. So you could say 12 hours and 48 minutes. And I'm okay with either one. But just include your units.